Let's see another example. So construct the true table for the statement given by P and Q or negation of R. So you can see clearly from the compound prepositions that there are three simple prepositions or statements, then to the power of 3, which is equal to 8 possible combinations of truth values. Then let's construct a table with three simple prepositions P, Q, R. Then we have 8 possible truth values. Then 8 divided by 2 is 4. So the first 4 rows will be true and the next 4 rows will be false. In dividing 4 by 2, it becomes 2. Then the first 2 rows becomes true and the second 2 rows becomes false, and then the second 2 rows becomes true and the last 2 rows becomes false. In dividing 2 by 2, it gives 1. So alternatively give true, false, true, false, true, false, true, false for the last simple preposition. And the next one is just the negation of R. Negation of R, which is the negation of true is false, the negation of false is true, the negation of true is false, the negation of false is true, the negation of true is false, the negation of false is true, the negation of true is false, the negation of false is true. And the next one is P and Q. P and Q, when as we have said for logical connectives, when we are connecting two simple propositions by logical connective conjunction or and, the compound preposition becomes true if and only if P and Q are true. Both P and Q are true. So otherwise it's false. Otherwise it's false. So P and Q, true implies true. True and true is true. True and true is true. True and false is false. True and false is false. False and true is false. False and true is false. False and false is false. And false is false. So this is the truth value for the P and Q. P and Q. And the last one is the compound preposition P and Q or negation of R. So we have P and Q here, and we have the negation of R is here, and they are connected by disjunction. So two simple propositions are connected by disjunction. Then the truth value for the disjunction, the compound preposition connected by the disjunction becomes false if both statements becomes false. If both statements becomes false. So applying that, let's use this one. False and false or true is true. True or true is true. False or false is false. False or true is true. False or false is false. True or false is true. False or false is false. True or false is true. So this is how to construct a truth table for this compound preposition. So this is the truth value for the compound preposition. Just as a remark, why we are using truth tables for important? Why are truth tables are important? Truth tables are give us complete information about the true role that the form of compound preposition plays in determining the truth of the compound preposition. And logical variables P, Q, R, etc. stands for infinite many prepositions, but these prepositions can take on only two truth values. Thus, there are only finitely many ways to assign the truth values to the logical expressions. And truth table lists the possible assignments together with the resulting truth values of the expression. And the truth table is a natural way to try to answer every question about logical expression, So when you come to logical equivalence, given two compound prepositions, then to say that the two compound prepositions are logically equivalent if they have the same truth value regardless of the components, the truth values of component prepositions. If they have the same truth value regardless of the component prepositions, then the two compound prepositions are said to be logically equivalent. They are said to be logically equivalent. So mean that their components simple propositions take on the same truth value, and then the expression taken on the same truth values, and we use the symbol this one to indicate that the two prepositions are logically equivalent. And for example, the expression P implies Q and negation of P or Q are logically equivalent. Let's show with the truth table. That's shown in the truth table. P implies Q. P implies Q becomes true when the second statement becomes true and the first one is false. The first statement is true and the second statement is false. It becomes false at this case. And the negation of P or Q, when two statements are connected by or, it becomes false if both statements becomes false. So both statements becomes false. So the negation of P is true here, false here. So we can false implies false is false. And that's the negation of otherwise it becomes true. Otherwise it becomes true. So clearly you can see that P implies Q is equivalent to negation of P or Q. Equivalent to negation of P or Q. As an example, prove that negation of P in the bracket, negation of P or Q is equivalent to negation of P and negation of Q. So we have two prepositions P and Q. So we have four possible combinations. So combination of truth values. So true, true, false, false, and true, false, true, false. Negation of P is which is false, which is also false, which is also true. This one is true, and this one is true. Negation of P is this one, and negation of Q is false, and this one is true, and this one is false, and this one is true. So negation of P and Q. Negation of P and Q. Negation of Q is this one. Negation of Q is this one. Negation of Q is this one. Then negation of P and Q. Negation of P and Q. But on the case of and, it becomes true when the two statements, the simple statements, becomes true. So it becomes true at this case. Otherwise, it's false. Now, what would be the case where the two statements are? Let's do first for the combination. Let's do first for the combination P or Q. Let's do first for the combination P or Q. Let's do first for the combination P or Q. P or Q becomes when two statements are connected by logical connective disjunction. It becomes true. It becomes false if both statements are false. Both statements are false statements. So it becomes last three here. It becomes still here true. It becomes here. False, and the other ones are true. The other ones are true. The other ones are true. So the negation of this one. So the negation of this one. The negation of this one is this one. False, false, true, true. Have you seen? And the negation, the other one is of the negation of P or and negation of Q. On the case of conjunction, it becomes true when the two statements becomes true. When the two statements are true. So clearly you can see that this one and this one are equivalent. This one and this one equivalent. So the compound prepositions, the negation of P or Q is equivalent to the negation of P and the negation of Q. So this is how to show prepositional equivalence and proves that these two are equivalent. Proves that these two are equivalent. So we have two statements P and Q. Then true, true, false, false. Give this one, and the next one alternatively true, false, true, false. So the negation of Q is what? What's the negation of Q? Negation of Q is false, true, false, true, and negation of P is false, false, true, true. Then P implies Q. When two prepositions are connected by logical connective implication, it becomes false if the first statement P becomes false, true, and the second statement Q becomes false. So when in the case of this one, it becomes a false statement. You can say that it's false, otherwise it gives true. And you can see that negation of Q implies P. Negation of P implies P. Similarly, they are connected by implication, and it becomes false when the second statement becomes false and the first statement becomes true. It becomes a false statement, otherwise it's true. So here is a point where negation of P becomes false, so it gives false, true, true, true. The other ones are true. So clearly you can see that these truth values and these truth values are equal. These truth values are equal regardless of the truth values of the other component or simple prepositions, so that the two prepositions are logically equivalent prepositions. They are logically equivalent prepositions. The next one is the converse, inverse, contrapositive of conditional preposition. So given a conditional preposition, if a number is divisible by 2 and 3, then it's divisible by 6. So in a conditional statement, the first statement, the first statement, if part is a hypothesis, and the then part is a conclusion part. So if, for instance, if a polygon has 4 sides, then it's a quadrilateral. So if a polygon has 4 sides, it's a hypothesis, and it is a quadrilateral, is a conclusion. The other one, if a number is greater than 2 is even, then it is not prime. So a number greater than 2 is even is a hypothesis, and it is not a prime, is a conclusion. So let's find the converse, inverse, and contrapositive of a conditional preposition. So the converse of a conditional statement is formed by interchanging the hypothesis and the conclusion. By changing the position of the hypothesis and the conclusion, we can find the converse of a given conditional statement. For example, if x minus y is positive, then x greater than y is a conditional statement, and the converse of this statement is changing this conclusion into hypothesis and this hypothesis into conclusion. If x is greater than y, then x minus y is positive, which is the converse of this statement. And the inverse can be formed by negating both the hypothesis and the conclusion, as they are seated or as they are seated in a conditional statement. We do not change the position of the hypothesis and the conclusion, but we negate them, or we apply not on the conditional statement. So the conditional statement given, if the angle is 75 degrees, then it's acute. Then the inverse of this statement is, if the angle is not 75 degree, then it's not acute, which is the inverse of the conditional statement. Similarly, and the last one, contrapositive. Contrapositive is formed by negating the hypothesis and the conclusion of the converse of a given conditional statement. So given a conditional statement, we apply the converse, and then we apply the inverse. Or we apply, given the conditional statement, we apply the inverse, and then we apply the converse on the inverse statement. So for instance, if the angle is 75 degree, then it's acute. If the angle is 75 degree, then it's acute. Its inverse is, if the angle is not 75 degree, then it's not acute. And this, the converse of this one is changing the conclusion to hypothesis, hypothesis to conclusion. So if the angle is not acute, then it's not 75 degree. So the converse, inverse, and the contrapositive given a conditional statement is obtained by this one. In a simple way, we can represent a mathematical form. Given P implies Q, given we have the P implies Q, the converse of this one is Q implies P. And the inverse of the P implies Q is negation of P implies negation of Q. And the contrapositive of this conditional statement is negation of Q implies negation of P. So we apply converse on the inverse, or we apply inverse on the converse. So the contrapositive is the inverse of the converse of the conditional statement, or we can say that it's the converse of the inverse of the conditional statement. So this is how to apply or find the converse, inverse, and contrapositive of a given conditional statement. The other one is a list of conditional equivalences. List of conditional equivalences. So the first one is P and true is equivalent to P. You know that when two prepositions are connected by and, they will give a true value, or they will give a true value if both statements are true, otherwise it's false. So it depends, this statement depends on the P value. If P is true, it becomes true. If P is false, it becomes false. So you can see that P and true is P, and P or false is also P. And similarly, when two propositions are connected by disjunction, they become false if both statements are false. So when P is true, it becomes P, true. When P is false, it becomes false. So P or false is P. So the law is said to be identity law. P or true is true, or P and false is false, which is a domination law, which means that whatever the P value is, the statement is the statement is true, because when we are connecting the statement by or, it becomes true if both statements are, it becomes false if both statements are false. But we have true here, whatever the p value, the truth value is true. Similarly for and, so it is which is called domination law. And the next one is P or P is P, P and P is also P. So it was just added potent law, is added for identity with P and P or P are the same. So we use P only. And the next one is double negation law. It's negation of a given preposition is a preposition itself, which is called the double negation law. And P or Q is equal to Q or P, and P and Q, which is equal to Q and P, which is just a commutative law of prepositions. And P or Q or R, which is equal to P or Q or R, which is just associative law. P and Q and R, and P and Q and R, which is just an associative law of logical connectives. The next laws are P or Q and R, which is just a distribution law, P or Q and P or R. So we distribute by or, and when we are distributing by and, it becomes P and Q or P and R. So it's just a distributive law. The next one is a De Morgan's law. By applying negation on the compound statement P connected by conjunction, disjunction, negation of P or Q, which is negation of P and negation of Q. When we are applying De Morgan's law, the negation changes the logical connective. If it is or, it changes into and. If it is and, it changes into and or. So negation of P and Q becomes negation of P or negation of Q. And the next one is P or negation of P is always true, which is tautology, and P and negation of P is false, which is a contradiction. The other one, P implies Q, is equivalent to negation of P or Q, which is implication equivalence. And the P by implies Q is equivalent to P implies Q, and Q by implies Q implies P, which is a binomial equivalence, which is called the binomial equivalence. And the last one is P implies Q is equivalent to P negation of Q implies negation of P, which is by the law of contrapositive. By the law of contrapositive, I think we have shown this one on the upper table, that the two statements were equivalent. The two statements were equivalent. The other good concept in this chapter is tautology and contradiction. So a given compound preposition is said to be tautology if the truth value it becomes true regardless of the truth values of the component prepositions. And the compound preposition is said to be contradiction if its truth value gives true false regardless of the truth values of the component prepositions. So for example, P or negation of P is a tautology. P, you have the two prepositions. We have two possible combinations of truth values. P, which is true and false, and negation of P is false and true, where we are connecting by the disjunction. The disjunction is false if the two prepositions are both false. So true, false is true, true or false or true is true. So it is just truth value. So the compound preposition P or negation of P is true preposition. So the next example is that P implies Q by implies negation of Q implies negation of P is a tautology. Clearly, we have two prepositions P and Q. So we have to the power of 2, which is 4 possible combinations of truth values. So we give true, true, false, false, and true for alternative. The next one, true, false, true, false, true, false. Negation of Q is 4, applying negation on Q and P. So P implies Q becomes false if the second statement false and the first statement is true. So it becomes false here, otherwise it's true. And negation of P implies negation of Q is the same. Negation of Q implies negation of P is false if the second statement is false and the first statement is true. Similarly, this one. So you can see that the two statements are logically equivalent statements, and they are connected by implication. The by implication statement becomes when two statements are connected by implication. The truth value for the by compound preposition connected by the by implication becomes true if they have the same truth value. The typical component prepositions have the same truth value, they become true, otherwise it's false. So false by implies false is true, true by implies true is true, true by implies true is true, true by implies true is true. So clearly the final final truth values of the compound preposition becomes true. So the given preposition, the given compound preposition is a tautology. The given preposition is in tautology. The next one is prove that P implies Q, by implies P and negation of Q is a contradiction, which means that prove that the truth value for the compound preposition is false. So we have two prepositions. So to the power of is 4, which is true, true. And the next one is false, false. And then true, false, alternatively, negation of Q becomes false, true, false, true. Then P implies Q. On the case of implies, it becomes false when the second statement false and the first statement is true. Then this one, true, true, otherwise it's true. And negation of P, negation of P, negation of P, and negation of Q. Or when two propositions are connected by and, they become true when the two statements are both true. So they become true. P and negation of Q is false, which is false. True and negation true and true is true. False and false is false, and false and true is false. So clearly we obtain that this one. Then P implies Q, by implies P and negation of Q, these two statements. So when we are connecting with two statements by implication, they become true when they have the same truth value, otherwise it's false. So true by implies false is false, false by implies true is false, true by implies false is false, true by implies false is false. So you can see that, the truth value for the compound preposition becomes all false, regardless of the truth value. So see the component prepositions, hence the given compound preposition is a contradiction. So thank you for watching this video. Please like, share, comment on the video lectures. Thank you very much.